So today we're diving into 11.3, dealing with area of a circle. But before we go too far into that, yesterday you guys dealt with pi. Who can remind me what pi really is? Now, I don't want the approximation because, yes, it can be approximated by 3.14. It could be approximated by 22 over 7. But how is pi actually found? How, in the past, or right now, can we get pi? Eli? I need everybody at the top of your notes to write pi equals, because if you can't answer this right now, you need to be able to answer this. Thomas?
So it's the area, it's the circumference of the circle divided by the diameter of the circle.
It is, and if we go back and look at yesterday's notes, when you had pi is the ratio of, I asked him to, and I hope you guys filled in, it's just the circumference divided by the diameter. It's also given to you right here in the notes. So I ask it to you over there. Now, you might want to pull out yesterday's notes really quick. I'm sorry, I know you've had your binder out and back down. But I want to make sure that you have the two main approximations that we use. Did you have the 3.14 and did you have 22 over 7? Those are the two main approximations that we use. This 3.14, or if you want it in rational form, like as a ratio, 22 over 7. Which of these is closer, 3.14 or 22 over 7?
No, they're actually...
22 over 7 gives me 3.1428, where pi is actually 3.1415, so they're both almost equally as close. 22 over 7 is slightly higher than the actual value of pi. 3.14 is slightly lower than the actual value of pi. But I need you on today's notes again to remind yourself that pi is circumference divided by diameter. We need to know that. And if you want to really make it easy for yourself, approximately 3. Your circumference of a circle is approximately 3 times the diameter. So if you know the diameter, about 3 times as much as the distance around. Now we start moving into area here though. So we want to talk about the area of something. Sorry, I forgot that I wanted to give you a little trick. So your formulas yesterday that you should have had, where that circumference is equal to pi times d, or circumference is equal to 2 times pi times r, those were listed right down here. But here's the way to remember it. Who, when we've been talking about pi, has thought about like an apple pie, or a cherry pie, or a chocolate pie, or any like a real pie? Because real pies are round. They're circular. So pi, pi, can be found in pi, pie, because it's round. Or pizza pie is round. This is kind of where pi came from. We can go down the whole like literary side of things. But crust. Think of, when I say C, think of crust. Crust is just pi dough. Like the dough for a pie, that's your crust. Crust is pi dough. You should never be able to forget how to find your circumference, because circumference is just pi times diameter, or crust is pi dough. So you might want to write down crust is pi, and I'm going to put that in quotations. Crust is pi dough, or crust is pi d. That's one way that has helped many kids realize, like, oh wait, circumference crust is pi dough. And if you don't know what d is, then you can replace it with 2r if you have to, but there's no nice little memory trick for that. So moving on to area. Now we're on today's notes, and I promise I will not leave here again. we could look at the area on this grid by using the grid boxes. Because if I look at this square, it has 1, 2, 3, 4 boxes fully inside of it. So its area, since we know each box is 1 foot by 1 foot, its area is 4 feet squared, or 4 square feet. Because we could find this area by doing the length of 2 times the width of 2, and 2 times 2 would give me 4, so I get about 4 square feet. Now if I look up here, what do you notice about the triangle that's pretty interesting? Thomas?
I think if I cut it in half and put like one side of the triangle like fitting into that one piece up.
So by cut in half, you mean vertically cut in half?
Yeah, vertically. Yeah,
and then you're talking about the little wedge up here?
Yeah.
So if Thomas took that
Put
wedge...
it down there in that whole place where the other triangle thing is.
This is where video games can be a help to your brain.
I know, right?
If you can imagine, let me
That's
cut
not a help
this.
to my brain.
Let me break it apart. Let me turn it. If we take this little wedge, turn it 90 degrees, it will fit right in this little space. Same with this little wedge over here. It would fit in this little space. So what would be the actual area of that triangle? Isaiah? 2. Because it would take up 2 full blocks. So that would be 2 feet squared. Now, can we do that with the circle?
No.
Circle.
The circle is really annoying.
Are round.
Now, here's a question that you guys may or may not have done, because middle school, this is always like, how much do your parents have you do? Has anyone ever ordered a pizza, multiple pizzas, and you don't eat all of it, and you're trying to condense the pizzas into like all in the same box to keep them for the next day? Has anyone ever taken a pizza slice and instead of putting it like point to point with the other pizza slice, you turn one around and you fit them together?
Oh, yeah.
So we have one pizza slice kind of like this, and my other pizza slice is kind of like that. And they fit together in the box kind of better because it takes up less space. You don't lose this gap around the outsides. Because if we think about finding the area of this circle, is there a way that I can chop a couple pieces off and rearrange it and figure it out like really easily?
No.
Circles are very hard to visualize how to find the area. But I'm going to show you a trick that makes circles way easier than you've ever seen. Here's what we can do with a circle, and it really does help if you imagine pizza. So we order a pizza.
You can use what you know about the area of a parallelogram to find the area of a circle.
Because it still plays through the video. So we got a pizza, right? We have to cut it to feed the class. So we decide to cut it into 8 pieces. Now, we're going to order more than a pizza, so don't freak out. So we take these pieces, and we find out that our friend, always we have that friend who's making these weird choices, our friend accidentally, instead of ordering square boxes for the pizzas to be delivered in, ordered rectangular boxes for the pizza to be delivered in. So essentially, the box that your friend got is about that big. Now, it's big enough for half of the pizza to fit in, but it's not big enough for the whole pizza to fit in.
Good job, Mr. Friend.
So, we, after scolding your friend and lowering their paycheck, we realized it's okay. We can rearrange my pizza to fit into a rectangular box. All we have to do is cut it and then take the slices and do exactly what we just discussed. Have one pointing up, one pointing down, one pointing up, one pointing down. So notice the height of the box would barely have to be more than the height of one pizza slice. So instead of being twice as tall as the pizza slices, we're only half as tall. And then I can lay them out longer. And actually, this is a more efficient use of area than it is to put a circle in a square box. So if pizza places actually wanted to reduce the amount of cardboard they use, they should be delivering all your pizzas set up like that.
But it'd be a lot more work because the employees would have to like flip them.
It would be a lot more work because the employees would have to flip things. But here's the interesting thing. if I start to approximate this, well, 4 of my slices, those crusts, 4 slices, that's half the pizza, right? So that would be half of the circumference. Well, notice those 4 crust pieces are right here. So the base of my kind of rectangle is really about half of my circumference. The height, what's the distance from the middle point of the pizza out to the edge of the pizza?
The radius.
That's the radius. So the height of my box just has to be the radius. So when I rearrange all these things, I could find the area of my rectangular box by using the length. Well, we said that's about half of the circumference. And the height, we said, is right about the radius. So we can just replace things and say, well, actually, my area can be half of the circumference times the radius. And if we do all the math, my circumference, we replace this with 2 times pi times r, or 2r times pi. Because remember, circumference was either pi d or pi times 2r. So we replace it with 2 times pi times r. So 2 times pi times r. Then times r again. Well, what happens when you have r times itself?
R squared.
R squared. When you have a number times itself, it's just that squared. What's half of 2? 1. So then we just get left with pi. So the area formula for my circle is just pi r squared. Come on, clear away. So right over here is your area formula, but I want you to write it bigger, somewhere where it's gonna like, you cannot forget it. Pi times radius squared. The area of a circle is pi times the radius squared. Now, depending on what we're told to use for pi, will depend on how close we get.
Pi divided by 4.
So we have an earthquake that's happened. Now I jump over here so it looks a little better. Make sure this got captured. Anyone know what the epicenter is? Yeah, but what's the epicenter? Brian?
Isn't it like where almost all the
People might say Nationwide Arena is the epicenter of Blue Jackets activity. It's the main point for everything to start. So an epicenter, if an event has an epicenter, that might be like the check-in table. Or if the school has an epicenter, that's probably like the office. But a hurricane or an earthquake has an epicenter, and that's the center of the event. So hurricanes all are like a storm. There's a middle of it. They call it the eye of the storm. That's the epicenter. And earthquakes have the same thing, where what triggers an earthquake? Shift in tectonic plates. So that shift, where that happened, would be the epicenter. So if we have a hurricane, it says the diameter of the eye of a certain hurricane was 30 miles. So we're looking at the eye of the hurricane. So let's say the diameter was 30 miles. To the nearest square miles, what was the area of the eye? And this, meteorologists will use to tell people how long do you have when the storm seems like it's over. How long will the break be before it kicks back up? Because when you're in the eye of the hurricane, you know that the other half of the storm is still on its way to come. So, yeah, you guys do not have this on your paper.
It's on the back.
How did that get out of order? That's really weird.
On the back.
Yeah, that's really weird.
That's
Good looking out. Good catch.
So, are we doing the rest of it?
Yeah, I also don't know why this took us to part 2 first. We're going to do this one, but I don't know why it went to part 2 first. I swear I hit part 1. So, what do we need to find the area? Do we need the diameter? Write down again. Always start by writing your formula. How do I find area? Pi times
pi times r squared.
radius squared. So what we need is the radius. If the diameter has been told to be 30, What's my radius? 15. It's just half of that. So to find my area, I'm going to do pi times 15 squared. But then pi, I'm told to use 3.14. So I'm really going to have 3.14 times 15 squared. Now here's the dangerous thing about using your calculator. I would type in the 15 squared, find that answer, and then do times 3.14. It's just to make sure you don't make any calculation mistakes. What do we find the area of that I to be? What is it?
706.5.
Now, especially when it says use 3.14 for pi, do not use your pi button. Your pi button is as exact as possible. Now, we still need a label for this. What would my label for area be? Miles squared. So we can either do miles squared, or you can do SQ period, MI period for square miles. So either do miles squared or do square miles. Now, if I can get this to actually go back to part 1 like I want. There we go. Flip back to the front, please. We have, and this is why I brought up an epicenter, we have the epicenter of an earthquake. It says the distance of intense shaking from the epicenter of a particular earthquake to the outer edge, so from the center to the outer edge, would that be the radius or the diameter? That'd be the radius, is 134. What to the nearest square mile is the area of the most intense shaking? So they can say, if you live here, you'll experience this. If you live here, you'll experience that. Using 3.14 for pi. Always start by writing pi r squared. The more you write it, the more you'll remember it. And then I'm going to replace, I'm told to use 3.14 for pi. My radius was 134, and I need to square that first. We're going to get a large answer here, because 134 squared.
5638.1.84.
Can we say it in proper form? Because I can't.
56,381.884.
884?
84.
Just 84. And then my label on that? Miles squared. Miles with the square, or you can write square miles, SQMI.
Oh.
Questions on how to do this? Try the got it on your own. Leave your answer in terms of pi. So you're not using anything for pi, it stays pi. The only thing you have to do here is square the 3.2. What is 3.2 squared? What is it, Cassie?
10.24.
10.24 or 10 and 24 hundredths? So if that's my 3.2 squared, it's 10.24 pi meter squared. When it says leave it in terms of pi, you literally just carry the pi through the problem. And it's in your answer. And it's delicious.
Oh, it is delicious.
I don't like pi. Instead of pi r squared, it should be pi r round.
Wait, the chocolate pie counts as a pie?
The pie is that.
Oh, well, I have eaten pie before.
I don't like pie. I don't like
Chocolate pie.
Now here's a really interesting question. What is the radius of a circle whose area and circumference have the same numerical value? So it's saying if they have the same numeric, so not that they're equal, because they can't be equal. One is length and one is area. But if the area was equal to the circumference numerically, well, area is pi times the radius squared. Circumference is 2 times.
Radius.
So yeah, I can do 2 times radius times pi. I could do pi d. Circumference is pi d. But I know that d is 2r. What can I do on both sides?
Divide by pi.
I could divide by pi. And that would give me r squared is equal to 2r. Well, r squared, I could actually rewrite that as r times r.
Divide by one of the r's.
Divide by one of the r's. If I divide r by r, that gives me 1. Because really, what we're doing is taking r squared divided by r, which gives me just r as the answer.
R equals 2. So R is equal.
So r is 2?
Let's find out.
That's honest, Hudson.
Let's check it. Let's calculate what would be the area if the radius was 2 and what would be the circumference. Well, let's do area first. Area would then equal, if my radius was 2, my diameter would be 4, so it would really just be 4 pi. I'm going to leave it in terms of pi right now. My circumference, we know crust is, area is pi r squared. I was doing circumference in my head. So if we do pi r squared, well, if my radius is 2 squared, I get 4 pi. My circumference is pi times the diameter, which if my radius is 2, my diameter is 4, I again get 4 pi. They come out to be the same numerical value. They're not actually equal because they're not the same label, but they get the same numerical value. So those are those interesting kind of math problems where you can say, how could I make area and circumference not equal but be the same value? Alright, so now part 2, we're going to move on to the got it since we already did the eye of the hurricane. So if you flip to the back and move on to bubble netting. Bubble netting is really weird. Water and bubbles floating up. So it's a hunting technique that humpbacks use. So the bubbles confuse the other fish. And they kind of make them feel like there's like other things there or other creatures. So it kind of scares them towards them. So what's the area of the ring of bubbles? 100 feet wide. So if you know that the ring is 100 feet wide.
So that would be the
Whoop. Try it on your own. Try it on your own. What did you guys think of the guest teacher?
It was so cool.
okay.
Was he? Should I put him on my list of like who I like?
Yeah.
Okay.
He has people of different places. Yeah, he has one foreign exchange student.
Oh, yeah, foreign exchange students. We kept one of those when I was in high school. Hey, Crystal, if this is 100 feet wide, would that be your diameter or your radius? Diameter, right? So, Bela, if this 100 is my diameter, what's my radius? So my radius is 50. It tells me to use 3.14 for pi. So, Zach, what'd you set up?
A equals 3.14 times 50 squared.
Here's a trick to numbers that end in zeros to square them. What's 5 squared?
24.
25. Remember, we're multiplying by itself, not adding by itself. And then double your zeros. So this is actually 2,500. 50 times 50 will give you 2,500, 50 50s. So this is really 2,500 times 3.14. And what do we get for our final answer? 7,850 feet squared. And we get our label from my diameter or my radius, whatever I had labeled, I use that label. Questions? So we did the 50 squared, and then we multiplied it by 3.14.
Wouldn't 50 squared be
No, because 50 times 50. You're thinking of 50 plus 50. When we square something, we're multiplying by itself. Yes, you guys, the square button is on the right side, or sorry, left side of your calculator.
It's like an arrow pointing up.
Well, you can use that. That's a power button. You can either use the button that looks like this and then type in 2, or the button that looks like this will take whatever you typed in and square it.
These calculators don't have them.
Yeah, I like the 30s better. This was on your supply list. You should all have a 30.
I have it in my locker. Mine magically disappeared.
Magically.
Actually, this is my sister's. It's not even mine.
All right, part 3. We decide to mess with a farmer.
What?
I'll wait till I have your attention. So, whether or not you believe in aliens is not what I'm here to talk about. Mr. Kabilo will do that if they do pseudoscience again. But crop circles are often talked about as signs of people, or people believing in aliens. And there's different ways to make crop circles. You can just
What are you doing here?
out through a field 'cause it'll
Making a
line
crop
out.
circle.
You can also take a board.
But
that's like
we're
a
making a
circle,
crop
and you,
circle.
like, stamp on it,
Uh-oh.
stamp on it, and it's got ropes like on the edge of it, so you can just pick it up as you go. Or aliens fly down to their spaceships and do whatever they do with their spaceship, and they leave us crop circles as signs that they were here. Don't know exactly which one I believe. You could also believe that some crop circles are man-made and some crop circles are inexplainable. But one crop circle has a diameter of 40 feet and another has a diameter of 80 feet. Is the area of the larger circle. Now make a prediction. If your diameter gets doubled, what effect is that going to have on your area? So think right now. Will it be doubled? Will it be more than doubled? Will it be less than doubled? Make your prediction in your head and then solve the area for each of these crop circles. Don't worry about the fact that they overlap. We'll start doing problems with that later on. Where, like, what's the area if I take away the overlap or things like that. Right now, just find the area of your big crop circle, the blue one, and the area of the small one, the red one. In my big one, if my diameter is 80, what's my radius? 40. And my little one, what's my radius? 20. Notice if we're comparing them, it doesn't tell you what to use for pi because it doesn't matter. You can leave pi as pi and be totally fine. So I'm going to leave my pi as pi.
When's Pi Day here?
I like Pi days.
It's March 14th. It's 314.
3.141592.
I'm 15. Do that for 15. Last year was 3.1. It was at the 920th second or something.
So because we're starting to run out of time, if you left these in terms of pi, which is way easier, you would have gotten 1,600 pi feet squared and 400 pi feet squared. So is my bigger circle double
Oh, it's quadruple.
It's quadruple. Now, why would this make sense? Why would it make sense that if I double my radius, I quadruple the area? Thomas?
I think this is because it's twice the diameter. I'm not the diameter. Yeah, the diameter is twice the.
Both is true. Yeah.
Yeah, and the radius is twice the thing.
So when I double my radius, look at what we're really doing. We then take it from pi r squared to pi times 2r squared. And when I double my radius before I square it, think about what happens when I do this math. The 2 would get squared. What's 2 squared?
4.
4 radius squared. So this, instead of just giving me double the area, gives me quadruple the area, because when the 2 gets squared, it turns into actually 4 times as much. So be careful when you talk about doubling the size of things. Or are you talking about doubling length? So are you talking about doubling area? What is it that we're actually trying to double? Because if you double the length here, like the distance across, you actually quadruple the area. And our last problem for today. How many of these smaller circles does it take to equal the bigger circle? I challenge you to do this without a calculator and without computations. Compare, huh?
What does computation mean?
Like what you're about to type into the calculator. Don't do that.
No, I wasn't.
Oh, it takes
I was
three.
clearing the memory of the calculator.
Compare their distances like we just did with the crop circles. How many of those smaller crop circles would it take to be the same area? How many of these smaller circles would it take to be the same area? We can all probably figure out that what's happening to my diameter is it's getting multiplied by 3. And that also means that the radius is also multiplied by 3. But if my radius gets multiplied by 3, how many little circles would it actually take to equal the bigger circle's area? How many, Oriana? 9. If you square your 3, if my radius is tripled, my area is nintupled. I don't even know. It's times 9. I don't know if nintupled is a word.
I don't think it is.
Probably not. There probably is a word for times 9.
It is.
But what is it?
I don't know.
Well, there you go.
Look it up.
You don't want to make it PG.
But it would take 9 of the smaller to fit the bigger.
I can only get it times 5. I don't even know.
All right, thank you guys. Have a great day.